Okay, so we are going to solve this system using the elimination method. The system is formed by the equations x plus 3y equals 10 and 9y plus 3x equal 30. We are going to follow the steps 1 through 8 again to solve the system of equations. So for step 1, and then and I want you to notice that the equations are in the standard form because the variables x and y are on one side of the equations. Okay. Okay, so let's get started. For the first step, we want to organize the equations so the x and the y's are above each other. In this case, we have, and let me erase this that I did here. Okay, so we can see that we have the x above the y's on the left side, and then we have the y's above the x as well, and we don't want that. We want x and y's to, on the same above each other. So we are going to rewrite the equation as, and I prefer to write the x first. X plus 3y equals 10. And for the second equation, I'm going to put the x in the first place, so I'm going to write 3x plus 9y equals 30. Okay? So that was my first step. My second step says pick the variable of your system you want to eliminate. In this case, in the first example, I eliminated the x. Now I'm going to pick the y to eliminate the y. Okay, to make it different. Okay, so I'm done with the first two steps. For the third step, I need to write the coefficients of the variable next to the other equation. The variable that I want to eliminate, in this case, the y coefficients. I have 3 and 9. I need to write them next to the equation, okay? And next to the other equation, and then I need to change the sign of one of them. If I have a negative, I have to make the negative positive, but in this case, the two coefficients are positive, so I want to I have to make negative one of them. So what I mean by this is I'm going to write my system. I have x plus 3y equals 10, and then I have 3x plus 9y equals 30. Okay? Okay? Let me rewrite the equal sign. Equals 30. Okay. So now, the step says, write the coefficients of the variable that you want to eliminate. The y variable has 3 and 9, okay? And then I'm going to switch. This is the coefficient of my first equation, so I'm going to write and multiply my second equation. The 9 is the coefficient of my second equation, so I'm going to write and multiply my first equation, okay? Okay, so I'm going to make one of them negative, okay? All of them are positive, that cannot be. When I multiply the coefficients, one of the products or the result of one of the multiplications have to be negative, so the variables cancel out. So I'm going to make one of the coefficients. Notice that both of them are positive, so I'm going to make one of them negative. In this case, it doesn't matter. I'm going to make negative the 9. Okay? Okay. So let me clean this. Yeah, we don't need this anymore here. So you understand me better. And then here, okay. Let me rewrite this. Let me rewrite this, and then let me rewrite this as 3, okay? Okay. So now, I'm going to perform step number 4. Now I have to apply the distributive property to my system. This means I need to multiply negative 9 by positive x. Negative by positive gives me negative, and 9 by 1 gives me negative 9x, okay? Then I have negative 9 by 3, that gives me negative, again, let me correct this, negative 27 y's, right? And then, let me rearrange this, what happened over space, equals 2. Okay, then I have negative 9 by positive 10 gives me negative 90. Negative 90. There you go. Okay, done with the first one. Now the second one. And I'm going to do something so you understand this more clearly. I'm going to write this 3 using another color. Let's use green. Okay, the first one. The positive 3 by positive 3x, that's going to give me positive 9x. Okay? Then I'm going to have positive 3, the positive 9 is going to give me positive 27 y's. And let me rewrite it again. Okay, positive, okay, I had said positive 27 y's equals 2, because that's the equal sign that is coming next. And then 3 times 30 gives me 90 here, positive 90 here. Right, so that was step 4. And then step 4 is done. I'm going to perform step 5. Step 5 says add like terms. So my like terms are these ladies here, these ladies here, and these gentlemen here, okay? So when I add negative 9x and positive 9x, they cancel each other out, so I have 0. When I add positive 27, negative 27 y's and positive 27, these cancel each other out, so I have 0. I bring down my equal sign. And then when I add negative 90 plus positive 90, these terms, they cancel each other out, so that gives me 0 here. So at the end, I have 0 equals 0. As you know, when the left side is equal to the right side, the system has infinite or many solutions. This means that these two lines, the lines of x plus 3y, and I'm just using this as an example. I'm not meaning that the lines are like this. I have one line, and then the line of 9x plus 9y, 9y, here, 9y plus 3x is on the top of the red line. So on the top of the red line. So because they intersect in many points, the system has infinite or many solutions. Okay?